You got to know it. It's geometric. You can't hold it. It's geometric. But you know it's there. Here, there, and everywhere. Gonna move. I'm gonna take you on a party ride. Who wants to go on a party ride? Geometric party ride. So we're gonna go back to some math because it's been too long. I know. And going back to something that we had done before we left. We were like in the middle of all of these things, and I believe that with the break, your brain has definitely, uh, you know, fought you on this. Geometric series, integral test, those things we had finished before, but I know that you have definitely forgotten them because I gave you a question on a Google form about geometric series, and it didn't go very well. So, what did that question look like? It looked like this. If possible, evaluate the sum. Okay, and the question was what you see right there. Uh, infinite sum for q equals 0 to infinity of 5 times negative 1/5 raised to the q power. That was the question. And thankfully, in the last few number of Google forms that were submitted, the actual answer won. So you see 44.7% chose the correct answer. The correct answer is 25/6. But for the longest time, because I was watching this, the blue one, series Divergence, was edging out the actual answer, and I was like, man, one, they've definitely forgot about geometric series because it's been a little while, and two, maybe we didn't do a good enough job the first time around. So here we are. I want to review geometric and integral test and talk about P series, and this is going to be the shortest video ever. I promise. This is going to be great. You're going to love it. So, you see the answer there, and I worked it out. But the big key for geometric series, and again, on this AP exam, you get to use your notes. So what you see there in blue and red, you need to write that down somewhere on a piece of paper and have it handy. Maybe I should actually put all the notes together and have them for you, but that'd be too easy for you and more work for me. So we'll see about that. But the geometric series has this special form. And when you think about the sigma, it kind of looks like the letter E in the English language, right? Sigma's an E, and it has AR to the n power. It literally almost spells out the word earn, like you want to make money, right? And a geometric series is similar to an exponential function. So like when we compound interest, right? You earn money. So geometric, it's got an exponent, right? Is there variable? And so maybe that would help you. The formula for geometric is it spells out earn. Now, of course, the sigma in the Greek letter is actually an S. So really it spells out sarn, but we're going to pretend like it's an E, okay? Earn. A times R to the n power. A is the initial amount. In banking, we call that the principal, or whenever you have a loan. So when we did all that exponential stuff last year in pre-cal or in algebra 2, we used P instead of A. And then the R was still R for the rate, and then it's to the n power. And so what I love about geometric series is it diverges and it converges by two simple rules. If R is greater than 1, it diverges. And it's also absolute value of R. So ignore the negative sign if it has one. And you notice this example has a negative sign. So you ignore it. What is the absolute value of negative 1/5? 1/5. Positive 1/5. And what do you know about positive 1/5? Positive 1/5 is less than 1. So this series converges. It does not diverge. So I can see how many of you thought it diverges because it goes to infinity. All right, that's the whole point of this whole series chapter in Calculus 2 is to look at series that go on forever but actually have an answer, which is pretty crazy. An infinite series has a finite sum. And when it's geometric, when it spells out earn, Martin, what you doing? Earn, you know that it can converge if R is less than 1. The absolute value of R is less than 1. And what's great about it is what it converges to. Not every series has that luxury. You don't always know what it converges to when it converges. Like we'll see today with the P series. This is a new rule we're going to get to today, a new formula, and it's a really simple one. It's not hard at all, but it doesn't tell you the whole story like this one does. It's kind of like one of those TV shows. You're like, this is really cool, and then after the first season, they quit making it, and you're like, oh, I don't really know where it goes. But for here, you have the first term A is 5, right? And then you do 1 minus R, and R is negative 1/5. So when you do the formula, A over 1 minus R, right? A over 1 minus R, this formula right here, I'm circling it, right? In the formula, you use R. You use the negative sign. When you're trying to figure out if it converges or diverges, you ignore the negative sign. But for the convergent formula of a geometric series, you use the negative sign. Okay, so notice how there's a big difference between absolute value of R and an actual R. Okay, so the convergence depends on the absolute value of R being less than 1. But then when you have the formula, it's A over 1 minus R. So A is 5. 5 divided by 1 minus negative 1/5. The minus and negative becomes plus 1/5. And 1 plus 1/5 is 5/5 plus 1/5 is 6/5. So 5 divided by 6/5, you multiply by the reciprocal, and 5 times 5 is 25 over 6. Okay, so I made this one up, hence the Q. That's kind of cute, huh? But yeah, 25/6, it converges to that number. That is an answer that it converges to. Geometric series. So I thought maybe we would just review a couple problems real quick. Whoops, I went too fast, way too quick. Hey, look, here's a cool one. 7 times 1/13 to the n power. And so right away, you can look at it and know if it converges or diverges. So does this converge or diverge? That was the point of this question mark right here. You look at 1/13. Is 1/13 bigger than 1? No. 1/13 is less than 1. And the absolute value of 1/13 is 1/13. So this series converges. Okay? As I've mentioned to you all, they're going to ask you about geometric series on this year's AP exam. So like you got to just know right to look there. Converge or diverge. That's the first step. Now what does it converge to? It will converge to A divided by 1 minus R. And A is what number? Everybody say it. 7. What's R? 1/13. So if you want, here we can pause it, work it out. Well, work it out after I tell you to pause it. Then you can work it out, and then unpause it after you work it out, and you can see the answer. Look, there it is. 91 over 12. 7 over 1 minus 13 is 12/13, and then the reciprocal of 12/13 is 91 twelfths. Well, 13 twelfths times 7. 91 twelfths. 13 times 7 is 91. Fun? Okay, example 2. Here's a good one. What about 7 times 13 to the n? Huh? Is 13 bigger than 1 or less than 1? Yes, very good. It's bigger than 1. So does this converge or diverge? Diverge. So when it diverges, you're finished. You can't go any further. So then what's happening here? Okay, so there was 2 examples of just convergence and divergence and what it converges to. Okay, so again, we already did geometric series. This was back like maybe even before March. Might have been the last week of February or last day of February. We had talked about convergent divergent series. Oops. So what we had not done yet, one of the things, at least I don't know that we did, was talk about this formula up here. Okay, A over 1 minus R. That formula only works when your series starts at 0. So this is kind of a big deal. With geometric series, have to start at 0. For pretty much every other series, it doesn't matter, but for geometric, it has to start at 0. That way, this A over 1 minus R works. Okay. Some series will start at 1. Some series will start at 0. Some series might start at 4 or 5 or 7. Okay. So what if it starts at 4? Like this one. See, this is a whole new world. This series doesn't start at 0. That's a problem. So you are supposed to recognize, oh, look, and that was it. Oh, I didn't mean to make that 1 over n. It's supposed to be 1 over, what was this earlier? think it's a 2. We're just going to make it a 2. If it doesn't start at 0, you can still know if it converges or diverges. So that's the first step. Does this converge or diverge? Raise your hand. Okay, I see. All right, very good. 40 out of 46. No, the answer. So good job. You other 6. Wake up. Wake up. You other 6. You know this one. Everybody say it together. 1, 2, 3. Converges. Yes. Okay. Because 1/2 is, what do you know about 1/2? It's less than 1, right? 1/2 is less than 1. It's also greater than 0. It's supposed to be between 0 and 1. Converges. Converges. But here's the thing. What does it converge to? It doesn't converge to a over 1 minus r, because a in this question is misleading. A right now looks like it should be the number 1, because in front of 1/2 there isn't a number, so the coefficient would be 1 of it, right? It's like 1 times 1/2. And if you were to do this problem using 1 as your a value, you would not get it right. So how do you do the ones when the bottom number isn't 0? I like to use the word you have to shift the series, kind of like a translation, right? Right now, this one starts at 4. We want to slide it, slide it here and there and everywhere. Hi, babe. Yeah. So we're going to electric slide it, geometric slide it back to 0. How do you do that? This is what I recommend you do. What I recommend you do is first figure out what this series looks like, okay? Plug in the first number. In this case, the first number is that 4. So what's the first term of this pattern? It's 1/2 to the 4th power. Plus, you add the next term. And again, 1/2 to the 4th power would mean a 1/2 times 1/2 times 1/2 times 1/2, which is a 1/16. Don't worry about that. Just make it 1/2 to the 4th. What would be the next term? 1/2 to the 5th. Plus, what's the next term? 1/2 to the 6th. Plus, and this goes on forever, right? So this is what's easy about this. When the bottom number is not a 0, write out the first few terms. You really only need to write out the first term. Maybe the second one helps you. But what you now have is what the a value should be if it started at 0. Remember, the a value is the first term in the sequence. That's the way it works, right? Like coming back up here to example 2, this one that did converge, right? 7 was my a value. When you plug in 0 to the power, 1/13 of the 0 makes 1, and that whole thing goes away because 1 times 7 is just 7. So if your first number of your sum doesn't start at 0, write out what the terms are, and then you know what it should start at. The first term of this series for n equals 0 to infinity would be 1/2 to the 4th. Like that is my a value. That first term is your a value every time. And now I scale it back to 0. Now, what am I multiplying 1/4 to the 1/2 by to get the next term? The next term in the pattern is 1/2 to the 5th. So what do I multiply 1/2 to the 4th by to get 1/2 to the 5th? Is you would multiply 1/2 to the 4th by another 1/2. So 1/2 to the 4th times 1/2 would make 1/2 to the 5th. That means this has to be 1/2 to the n power. Say what? So if you don't believe me, check the series now. Start with 0, plug in 0, and see if you get the same thing, right? Plug in 0, and 1/2 to the 0 makes 1, times 1/2 to the 4th is 1/2, to the 4th, right? God bless. Plus, now plug in 1. What's 1/2 to the 1? 1/2 to the 1 is a 1/2, times a 1/2 to the 4th would make a 1/2 to the 5th. Plus, and that would just keep happening. So it is for term the same series as what's above it, right? It was up above it. So, anywho, now that I have it reset at 0, I know it converges because 1/2 is still between 0 and 1, right? It still converges. What does it converge to? It will converge to a over 1 minus r. In this problem, what number is a? A is the number in front of the exponent factor. So a is 1/2 to the 4th power divided by 1 minus r, which is a half. And 1/2 to the 4th, 1/2 times a half times a half times a half is a 16th, because 2 times 2 is 4 times 2 times 2, which is another 4, makes 16, and 1 over 16 is 1/2 to the 4th. And then I'm dividing that by a half minus 1 minus a half, which is a half. So I get 1/16 times 2 over 1 makes 2 over 16, which is an eighth. And that 1/8 is the value of the series convergence, right? It's what it does converge to. No, this series would converge to an eighth, right? And again, what is this series? The actual series. Goodness, this is annoying. The actual series here, right? This series is actually 1/16 plus 1/32 plus 1/64 plus forever and ever and ever forever, all the way to infinity. It would add up to 1/8. The sum would be 1/8. Okay, cool. So if you look in the book, I actually picked this problem from the Larson book. And in the Larson, this is on page 598 in the Larson book. I thought about doing it his way, but I'm not going to do it. It's actually example 4 in his book too. He does this a whole nother way. He gets the 1/8 a completely different way, which is fine. I kind of don't like it, honestly. He just has you pretend it starts at 0 and then get the answer using the original series with 0. And then you have to subtract the first 3 terms off of it, or the first 4 terms, because 0, 1, 2, 3. So the first 4 terms you subtract off, you get the 1/8. You can look at his book if you want, but I'm just going to keep practicing this same problem. So here's another example. After 4 is 4.5. Okay. I thought I'd do another one with you, and then I even have a third one where you can try it on your own and see if you got it right. So example 4.5. Again, what's the first step? The first step is realizing, oh, it's a geometric problem. And the good news is, guys, you don't have a bunch of series on the AP exam this year. You have geometric, you have P series, alternating series, and the ratio test for series. And so recognizing a geometric should be easier than ever. That's my hope. And so this one, notice it's E times A to the R in power. It spells out earn, right? Gonna make some money to get this bread. Hashtag gluten free. It's geometric. All geometric have this formula to it. Now the problem with this is it does not start at 0. It doesn't. Does it converge or diverge? Well, look, it converges, right? Everybody said it converges. If it diverges, you'd be done. You don't care that it doesn't start at 0. If it diverges, you're done, right? Change this to a 3/2. It diverges. There's nothing else to do. You won't find its convergent solution because it doesn't converge, right? So the fact that it starts with a 3 means, oh, it's got to converge, and I'm going to have to do some extra work to figure out what it converges to. So how do we do this? What I would recommend is write out all the terms. The first thing you do is plug in 3. So when you plug in 3, what do you get? You get 2 times 2/3 to the 3. And I know that 2/3 cubed is 8 over 27. And I know that 8/27 times 2 is 16/27. But don't worry about that yet. Worry about that later. That's just the first term. Just write it as it is. Next term be, next term would have a power of, or if I said, like you're golfing, 4, right? Are we golfing? Yeah, let me make some eye contact. 4. 4. We're golfing. 2 times 2/3 to the 4 plus 2 times 2/3 to the 5 plus we go on forever and ever and ever and ever. So again, the first step is write out what the series would equal. That's what it would equal. So what you can do now is, I'm gonna scroll up so I got more room, is you can now rewrite the series in terms of n equals 0 to infinity. And how do you do that? You want the first term in the sequence, right? The first number, the coefficient of the variable factor. See, the variable factor here, right, is 2/3 to the n power. The coefficient is 2. I don't want the coefficient to be 2 because at 2, it doesn't start at 0. So to start it at 0, you want the coefficient to be this. 2 times 2/3 to the third. That is now my A value. Okay, and what am I going to times that by? I'm going to times that by something to the n power. Well, what do I times 2/3 to the third by to make it 2/3 to the fourth? Right? You need another factor of 2/3. 2/3 cubed times another 2/3 would be 2/3 to the fourth. So I need another 2/3 here to keep adding on those powers, right? 4, 5, 6, 7, etc. So there's the series rewritten in terms of 0. It's like a phase shift. It's a horizontal translation. We're sliding the series back to the start, or as Coldplay would say, right? Back to the start. Yeah. So now I know it converges. Why does it converge? It converges because 2/3 is less than 1. Okay, it's also greater than 0. And it's a positive 2/3. I don't need to take the absolute value of it. But what does it converge to? It will converge. Matter of fact, let me give myself more space. It will converge to A over 1 minus R. That's the formula to remember. And the good news is you don't have to remember it. You write it down and you'll be able to look at it. Okay. AP exam, you want to have your notes ready. You don't want to have to Google stuff. Because 1, it'll slow you down. 2, they're going to be watching the Google. Okay, they're going to know you're trying to Google stuff. Promise. They're watching. What number is A? A is the initial amount. That's the number that comes in front of the variable factor. This right here is A times R to the N, right? Earn, making that money. And so A is 2 times 2/3 to the third divided by, what are we divided by? 1 minus R. What's R? R is 2/3. And the rest of this, as they say, is easy. You know, red and blue make purple. The numerator is 2/3 times 2/3 times 2/3, which is 8/27. And what's 8/27 times 2? 16/27. No calculator should be needed there. What's 1 minus 2/3? 1/3. Now what you're going to do is multiply by the reciprocal. The reciprocal of 1/3 is 3. So what's 16 times 3? Don't do that. What you want to do instead is take 16/27 times it by 3. Just divide the 3 into the 27. How many times does 3 go into 27? 3 goes into 27, right? 9 times. So this fraction will reduce to 16/9. That is what the series would converge to. 16/9, which is like 1 point close to 2, right? 1 point, whatever 7/9 is. You guys can figure it out. Again, no calculator needed. You do get to use a calculator on this AP exam. You can have it handy, but what they are saying is that none of the questions will require a calculator. So they're not going to ask crazy decimals of you. They're not going to ask you to know the ln of 7, because you'll just leave the answer as the ln of 7. So there's another example here. I'm going to scroll up slowly because I wrote the answers. If you need to go back and watch that one, go back and watch it. So I made another example right here, 4.9. The sum from 2 to 8, 2 to 8, 2 to infinity, 2 to 8, 2 to more like 2 to late. I'm tired. It's late. You look at the bottom corner, the clock says 10:58. I started making this video a long time ago, like a week ago. It's late now. So I have the answer worked out. I'm going to scroll to it so you can pause now. Try to figure out on your own. Okay, pause it. Okay, unpause it. The answer is 1/12. 1/12. and I hope I'm right. I'm making these up, so sometimes I use his examples in the book, but this is me just making them up. Again, write out what the series means. Plug in 2, plug in 3, plug in 4. I mean, it is possible that I messed these up. I don't think I did. When you plug in 2, you get 1/4 squared. 1/4 cubed when you plug in 3. 1/4 to the fourth when you plug in 4. So that means you want 1/4 squared is your A term, the first term, and then your series gets to start at 0 like it's supposed to. How do you get the next term in the pattern? The next term comes from multiplying by 1/4 again, right? So the variable factor, the variable has to be 1/4 to the n. And so A is 1/4 squared. Undo, 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 undo. A is 1/4 squared, that's A, right? Over 1 minus a fourth, because a fourth is R. And a 16th divided by 3/4, multiplied by the reciprocal, 1/12. So there's a whole lot more with geometric series than you probably really care about, but you forgot at least. This should definitely make the AP exam so much better. Back when we did this, I did not know that this was one of the 3, 4 rules you had to know for series. Geometric series is a big one. It's good. Okay, so I need to scroll back to this right here. This. It's all about this. So if you need to pause it right now, the geometric series is the form for n equals, the sum from n equals 0 to infinity of a times r to the n. It diverges when r is greater than 1. It converges when r is less than 1. That's like the big thing, and it converges to a over 1 minus r. Goodness gracious. You made that prayer. So what's next? I did a little screenshot here. Man, I'm still going back in time. Sorry, guys. I was going to make a short video. It can't be possible. The AP exam this year is going to have 5 sections. 10-2, 10-5, 10-7, 10-8, 10-11, according to the AP exams numbering of things. There are normally 15 sections here in Unit 10. So they've cut 10 sections. These are the 5. 10-2 is working with geometric series, which we just did. Again, 10-3, I wrote up here at the top, was the nth term test for divergence. We talked about that before, so you can go back and read that for fun. That's the one that says, if you want to know if a series diverges, you look at the limit of the sequence. I should have written it up here. I guess it says, if the limit as n approaches infinity of a sub n, you look at the limit of the sequence. You look at the pattern, and if it's not going to 0, then the series diverges. That's the answer. It's not on the AP exam this year. That's 10-3. They cut 10-3, but we already did it. 10-4 is the integral test. Notice 10-4 is not on the AP exam this year. On the AP exam, you have these 5 sections over here. But I'm mentioning 10-4 again because, one, we already did it. We did it twice because we did improper integrals like a long time ago. And then when I talked about the integral test, I was like, hey, guys, it's just improper integrals again with a twist. 10-4 is actually really important because it pretty much develops the P-series. When you look in Larson's book, Larson puts integral test and P-series in the same section. Okay? This is one, oops. This is one section in Larson's book. It's literally called the integral test and P-series or something like that. Puts them together. Because when you use the integral test a few number of times, you develop what a rule for P-series. P-series is like the best rule ever. We're almost done, I promise. Like another 45 more minutes. The integral test, what that said back in Larson's book, chapter 9, whatever it was, and this was something we had been doing right before we were out of school, is if you have a series and the integral, they either both converge or both diverge. They do the same thing. So you could almost use an integral test for every single series ever. Ever, okay? Even the geometric ones that we just did, you could use an integral test. It would just take you longer because you already know when you look at the geometry, you're supposed to just look at it and you go, oh, it's geometric. Boogie, woogie, woogie. I'm done, to get this bread. It's geometric. But you could use an integral test. what you do for the integral test is you literally integrate the series. You turn the series, so you look at example 5 here. You turn the series from 1 to infinity of 1 over n into an integral. So there's my integral from 1 to infinity of 1 over x dx. And you can even do the integral in terms of n. Make this 1 over n dn. Personally, I'm fine with that. Like I think it's fine. Why change the variable? But they always do. Or yeah, because the math professors are just smarter than I am. But hell, you can integrate using different variables. But this is and we did this problem already. The sum for 1 over n. And notice this series starts at 1. You might think, why does it start at 1? Why does it start at 0? Well, you can't have 1 over 0. So this series can't start at 0. Can it start at a half? Sure. Make it a 1/2. Okay. But normally we always let in the whole numbers. So can it start at 4? Sure. Make it a 4. You can do that too. That makes this integral a 4. The issue is it's not the 4 that's a problem, it's the infinity on top that makes this one a problem. So this series literally means what is 1 plus 1/2 plus 1/3 plus 1/4 plus. And it turns out using the integral test, right? So let me ask you, see how this is an equal sign and it's blank here. What is the integral of dx over x? Or the integral of 1 over x dx? This is something that we should know, that we've done before. The integral of dx over x is the ln of the absolute value of x. And I don't need a plus c because I'm going to go from 1 to infinity. Right? So now I'm going to plug in infinity. And I think in 6th period and 7th period, both, I showed an improper integral like one time doing it the right way. What you're supposed to do is change the infinity to a different letter, like a letter b, and then you would take the limit as b approaches infinity of the ln of b. And as b gets bigger and bigger and bigger, well, the natural log function gets bigger and bigger and bigger. So the way I wrote it here, just for time, because one, the integral test is not on the AP exam anyway, so we don't have to worry about the notation. But technically, this isn't really written correctly. But the ln of infinity is infinity, right? As x gets bigger, the ln of x gets bigger. So it's infinity minus the ln of 1 is 0. And infinity means that there is no limit, right? It means the integral goes on forever. It doesn't have an answer. It diverges. So since this integral diverges, I know that this series diverges because the integral test says they both either diverge or converge. Okay, the integral test can be used on any series ever. The problem with it is sometimes it's an integral I don't know how to do by hand. So, like we've said before, you can always make up an integral that's like impossible. So it works in certain scenarios better than others, but you can always try it for any series. Try to integrate it. If you get an answer besides infinity, then it converges. If you get infinity, it diverges. Cool, right? So I'm talking about integral test, and we don't need to know integral test. The integral test is 10-4 in the AP exams curriculum. Okay, 10-4. Good, buddy. So something worth mentioning, though, now that we're there, and you musicians that are listening, smarter than me, this series, the integral from 1 to infinity of 1 over n, 1 plus a half plus a third plus a fourth is called the harmonic series. Okay, and it has to do with, I've read about it 100 times and I always forget how to really explain it. But, in music, right, like when you vibrate like a string on an instrument, uh, the harmonies, the wavelengths of the string have to do with the pattern 1/2, 1/3, 1/4. Like the wavelength of the vibration of the string um, makes this pattern of numbers. Whoa, it's probably something that like Pythagoras came up with back in the day. But so this is what's called the harmonic series. So you notice up here in the 10-5 P, harmonic and P series. Okay, the harmonic series is one specific case of a P series. The harmonic series is when n has an exponent of what? What is the exponent on n? What is its power? Power, the power of n. The power power is 1. And notice the word power starts with the letter P. So the power of n is 1. When the power of n is 1, you have a harmonic series, even if you add extra stuff to it, okay? Notice this is like 1 over 2n. It's still n to the first power. That series diverges. What if it's 1 over 3n plus 9? 3n plus 9 is n to what power? The power of n is 1. If the denominator's power is a 1, and there's no variables on top, notice on top you have a number. So if it's like 7 over 13n plus 74, okay? All of these examples of series are harmonic series, and all harmonic series diverge. It will always diverge. If you have a harmonic series, it diverges. On the AP exam, when they ask you like, how do you know if this series converges or diverges? You can use different rules. You could say, oh, it diverges by a P-series test, or it diverges by the integral test. And those could be almost the same thing. If it's harmonic, what you'll see on the answer keys, on the rubrics, when they're harmonic, they'll say it diverges because it's harmonic. So if it's harmonic, you can just know it diverges. But it diverges by the integral test, right? Because the integral test is for every single one of these rules right here. When you integrate them, you get an ln. You get it with some coefficient, right? The coefficient might be a 1 or a 1/3, or maybe the coefficient is a 7/13. But it'd be 7/13 the ln of 13n plus 74, which as n goes to infinity, the ln of 13n plus 74 goes to infinity. So it diverges. So harmonic series always diverge. What makes it a harmonic series is the power of n is 1. Okay, so what if the power of n in the denominator of this series is not 1? That's example 2. In example 2, I already worked it all out. So just to go through this quickly, because I know we're like, okay, we're done with this card. 1 over n squared. It's a different power, right? Notice the power of n is 2. And how would I integrate 1 over n squared? Well, I make it x squared, dx over x squared. Then you move the x squared up and it becomes a negative power, right? And how do I integrate x to the negative second? It's power rule. Whoop, whoop. Here we go. This might be the last time, right? Whoop, whoop, whoop. Raise it up. Power rule, right? So since 37 minutes, God bless America. Land that I love. I'm almost done. I promise. Like, I'll try to cut this to like 3 more minutes. We'll be done. -2 plus 1 is -1. The reciprocal of -1 is -1. So the integral is negative x to the -1, which is really -1 over x. And then I'm going to go from 1 to infinity. So notice what happens here. That did not happen before in example 5, right? When we had n to the first power. Was when I plug in infinity now, 1 over infinity, or technically I'm supposed to plug in a letter like q, and then I take the limit as q approaches infinity. So what happens to -1 over q as q approaches infinity? Again, that goes to 0, right? Because the denominator would get larger and larger and larger, and -1 over a larger and larger and larger number is a smaller and smaller and smaller number. So degree of the numerator is less than the degree of the denominator. 1 over infinity is 0. Cut a pizza into infinity pieces, you don't get to eat anything, right? And then what's 1 plus 1 over 1? Because now I plug in 1 here, and notice that it is a minus minus. That's why there's a plus. Because usually when you integrate, you put a minus, but it's a -1 on top, so it becomes a plus 1. And 0 plus 1 is 1, which means it converges. This series will converge because its integral has an answer, right? When the integral ends up equaling infinity, that's not an answer. That's not a limit. That's diverges. When the integral is a number, any number, the series will converge because the integral converges to a number, okay? So I know that this series converges. What's slightly annoying about this, maybe make more words here, 1 over x squared, 1 over n squared would look like this. That's the graph of it. And if I start at 1, right, 1 is here. And so when I do the improper integral is going to add up the area under the curve. The area is 1. That answer 1. that would be the area. Even though the graph goes on forever, and the graph and the x-axis never, ever, ever touch, it's not a bounded region, but it does have an answer, which is really cool. When we did example 5 earlier, it didn't have an answer. It was unbounded forever. The answer was infinity too. What's weird about this is I do not know what the series converges to. Okay, just think about what the series means. The series, this thing, means plug in 1. 1 over 1 squared would be 1 over 1, which is 1, plus plug in 2. What's 2 squared? That's 4, and 1 over 4 is 1/4. Plus plug in 3, that would be a 9th. Plus plug in 4, a 16th, plus forever and ever and ever. So if you add up all those numbers, add up the red numbers, 1 plus a 4th, plus a 9th, plus a 16th, plus a 25th, plus a 36, plus a 49th. This sum would be bigger than 1, right? So what's interesting about this is I know that this series converges. It converges by the integral test, okay? But I don't know what it converges to. To figure out what it converges to, I would need to add up like a bunch of these numbers. And we've talked about that before, a sequence of partial sums. Add up a bunch of them. Add up like 5, 6, 7, 10, 100. If you added up like 100 of the terms, you'd pretty much know what it converges to because the answer wouldn't change much after you get to 100th, 100. So the integral converges to 1. That 1 does represent the area under the curve, but that 1 is not the answer for the series. The 1 just tells me the series converges. It's not what the series converges to. And that's sort of a pain in the butt. Okay, so I could keep doing this integral test. And I'm sorry, because I know you're saying we don't need to know the integral test. But like I said, in Larson's book, the integral test and p-series go together. Okay? Because if I kept doing this integral test and I changed the n to a third power, change the n to a fourth power, change the n to a 5/7 power, change the n to a 7/5 power, keep trying different powers. Eventually you would get to this theorem 9.11, a p-series, right? And what does a p-series say? P-series is one of the best convergence formulas. So I don't need to know integral test. I don't need to do any of this math that I just showed you, except for the fact that it's important. What does the p-series say? This is going to make everything so much better, promise. P-series says that if I have a series of the form 1 over n to the p power, okay? P is the power of n. P is going to be a number, okay? That power is a number. If the number is bigger than 1, the series converges. If the number is less than or equal to 1, but also greater than 0, it diverges. Now, what's annoying here is these are the exact same rules that are not the geometric rules. They're the exact same opposite rules of geometric, right? For geometric, remember the series diverges when r was greater than 1, and it converges when r was between 0 and 1. So p-series and a geometric series are completely opposites. It's like the rules for football versus the rules for spin the bottle. Just completely different, totally different, completely different. So the good news is, though, a p-series is one of the most easily recognizable series things, and then the fact that they gave you this as one of the rules is so great for the AP exam because they're pretty fast and quick. It should be really easy to recognize. I can't wait to see how they can make this trickier than it is, but I'm sure they will. Example 7. Oh man, it got tricky all of a sudden. Here's a series, and you might think, what do I do? Is it geometric? It's actually not geometric. Remember, to be geometric, the number r is to a variable power. The number r is to geometric. Now you're like, dang it, Quirk, you don't need to write this down again. Geometric is a times r to the n. A and r are numbers. This is the variable. It's like an exponential function. I can't spell. Variable. Numbers. So example 7 turns into, I don't know what color green I used. guess it was this one. 1 infinity 1 over n to what power? If you have a square root, that's what exponent. What is the power when you rewrite the square root? It's a 1/2. What do you know about the number 1/2? The number 1/2 is between 0 and 1. If p is between 0 and 1, maybe I should write it that way, then it diverges by p series. A lot of times in the AP exam, when they say, like, does it diverge or converge, you're supposed to give the series, like, even explain why. Diverges because p series, the p is less than 1, you know? So, like, that's all there is to 7. If you're to use the integral test on 7, it would work. You could use the integral test, and it would be infinity as the answer in the end, and that doesn't work. So it diverges. You cannot use geometric rule on 7 because it's not a geometric formula. It doesn't match the pattern. Okay. If you try the nth term test for divergence, it would be inconclusive because the pattern 1 over the square root of n, as n gets bigger and bigger and bigger, goes to 0. And it has to not equal 0 for you to know it diverges. So even though this does diverge, the nth term test doesn't tell you that it diverges. Okay, so this is what makes all these series rules really tricky because you have to really know them all to be able to play the game. You know, like before you play any game, you gotta know the rules. You know, it kind of sucks when you play a game. People are like, "Oh no, you can't do that." You're like, "Well, I'm just learning. I don't know this yet." So that's what's happening. We're expecting you to be masters of this, be able to play the game, and you're like, "I'm just learning." So example 8, uh, 1 over the square root of n cubed. How do you rewrite the square root of n cubed? What is the power? What is the p? It's 1 over n to the, how do you rewrite square root? Everybody say it together. 1, 2, 3. 3/2. 3 is the numerator. The 1/2, the divided by 2, is the index of the radical, so it's 3/2. And what do you know about 3/2? The number 3/2 is bigger than 1. 3/2 is 1.5. 3/2 is greater than 1. Converges by p series. It's really a great rule because you know right away converges or diverges. There isn't any of this sort of like, well, maybe not if it's a Tuesday, you know. Um, it's straightforward. It's one or the other, just like geometric. It's one or the other. Converges or diverges. You just got to know it. And the good news about knowing it is you can just write this formula down. So what you see right here in this box, right? That's your P series rule. Last one. Notice this one starts at n equals 7. That's fine. I know up here in the thing it says 1. Oh, Marty did an eraser. When did I do that eraser? That could have been months ago. Dang it. That's supposed to be an infinity on. See right here? I erased it with my finger. If I keep hitting undo, I'll get there eventually, but forget it. Redo. This problem starts at 7. No big deal. It's okay if it starts at 7. It doesn't have to start at 1. Doesn't have to. Because what I'm learning is I know these converge or diverge by a certain formula, but I don't know what they converge or diverge to. That's the thing about P series. It doesn't tell me the sum like a geometric does. So I'm promising you guys, there's got to be a question on geometric on this AP exam. Because it's nice because you can tell if it converges or diverges. You also know what it converges to. So does this converge or diverge? 74 is greater than 1. Converges by P series. And is force compensate. That's all I gotta say about that. That's all I gotta say about the P series. It's a pretty simple rule. You see up here in the box. Maybe go back and write this down. Pause it and write this formula down if you haven't done that yet. Go away, page 7 to 7. P series basically comes from the integral test, right? If I were to use the integral test here, it would converge. So cool. So I hope you had tons of fun here. P series. I'll put some problems on the Google Classroom. What else? Geometric. I'll probably put some geometric numbers on a Google Classroom. But for right now, all I got to say is bye. Hearts. 49-49.